Okay, so this is a quick recording for those of you that were absent for the projectile motion lab. Should just be specifically Garrett and Steph. So first of all, we're going to be using a simulation program, and the simulation program is listed under the news links. So if you need to find it, if you go under news on Moodle, you'll see the link there. The lab is also on Moodle, so let me bring up the Moodle page so you can see that first. Well, here's the news forum. So if you look at our news forum, you'll see right here is the Projectile Motion Lab website. So if you click on this, you'll see here is the actual link. We click on the link, and it brings right up to the lab. Okay, this is the lab program we're going to use. Let's go back to Moodle, though, so you can see now. So in our physics class, if you go to handouts, you'll see Lab 3 is here also. So if you want to print a copy of the lab, it's right there. You should have a copy, though. Steph, Kareem, and Gabby have your copy. Garrett, you don't have a copy. You need to print Lab 3 from here. Alright, so back to the lab. Your goal for this lab is to understand and identify the important angles when looking at projectile motion. For example, we're going to try and determine the angle that provides the maximum range or the maximum x displacement. So there's a little introduction. I'd like you to read that, obviously. But your main goal for this first part, for part 1 here, using the program, okay, using the program that I just showed you a second ago, so we're going to be using this program right here, which is linked to the news. You want to first, for part A, find the maximum range of a projectile at 20 meters per second. Notice right here, 20 meters per second. So you might want to change this. This is going to read at 18 originally. So click on this, make it 20, please. Okay, once that is 20, you can then change your object also. Change your object to a football, as instructed in the lab. Click on football, please. Now, what your goal is to keep changing this angle that I've highlighted right here until you can get the object to travel as far as possible in the x direction, which happens to be called range in physics, the range of the projectile, which is not to be confused with the range or domain from math. The range in math indicates the y components of the set, and the domain indicates the x. But when you hear range in physics, we're talking about the x displacement now. So if I launch this object at an angle of 25 degrees, I'll hit fire, and we'll see. And we can take a look up here at the upper left. We'll see the range was 33.7 meters. Now, that range can get larger. So if I take this angle and maybe make it like 30 degrees, and then hit fire again, it's no longer 33.7, it's 37.3 now. Turns out they happen to be switching numbers, but it increased, though. That's what you're looking for. So then keep going. Maybe move it up to 35 degrees, and then hit fire. And that one goes even further, we'll notice. So what you're going to notice is that you're going to keep changing the angle to get the maximum range. And what you'll see later is that if you exceed a certain value, which you have to figure out, so say we get all the way up to 60, well, if I shoot it at 60 degrees, now the range is not nearly as far. Okay, it's much shorter. So you have to keep trying to change this angle here, change this angle, and you can think there are 90 possibilities, you know, all the way from 1 degree all the way through 90 degrees to get the largest range value up here. So continue to change this angle until you get the largest possible value. Now, that value will go right here under the target for maximum range for part A. Along with that, I want you to please write down the launch angle that you chose. So say your launch angle turned out to be 50 degrees and you got the max, or 45, or 40, or 35. That's for you to figure out. That angle that you have right here, highlighted, is going to go in this box here. The next thing you want to do is write down the max height. To find the max height, it's a little bit tricky, so let me clear this so you can see better. So if I launch an angle, or if I launch a projectile at a 50-degree angle, and I want the max height, unfortunately the height listed here is negative 1.2, which is really just the difference between the starting point and the ending point. So that's not going to help me too much. But what I do want to look at is the max height of the projectile from the top of its path. So we take this object here, which is like your tape measure, and you'll notice you can move the tape measure. It's probably on the ground. When you start the lab, it's usually down here on the ground. So grab the tape measure, move it so that the tape measure is at the top of the path, the plus sign. Then grab this end of the plus sign and move it so that it's perpendicular to the floor. Now the hard part here is to line up the plus sign with the football. So you want this plus sign down here to be lined up with this football over here. And you'll see that this max height turns out to be 13.37. It's not going to be what your answer is, but just an example of how to find the max height. That will go here in this box. Finally, the hang time goes in the last box, which is given right here at the top. So the hang time for this example would be 3.2 seconds. Again, 3.2 seconds. Now, part B for the lab, part B. Part B asks you to find two launch angles such that the projectile has a range of 20 meters. One of those launch angles will be greater than 45 degrees, while the other will be less than 45 degrees. So for example, if I change this launch angle, say to 70 degrees, and I hit fire, what I notice is that it ends up with a range of 26.7 meters. Well, that's too much. I want to get 20 meters exactly. So I might have to make this a little bit larger of an angle. So 75 degrees. Let's see what our range turns out to be there. Oh, then our range is closer. It's getting closer and closer to 20 meters. So this one happens to be 20.71. So your goal for part B is to keep altering this angle so that you get a range of 20 meters up here. If you get like 19.9 or 20.1, that's close enough. Now, with that said, you're going to have one launch angle here. That might be 70 something. And then the other launch angle here. Well, the other launch angle is going to be a number less than 45. So for example, if I tried 15 degrees, I'll see that, well, my range is 24. So I might want to change this to like 14 degrees. Well, then my range goes down to 23. So keep changing it. Now, you'll notice that one of your angles here is less than 45. That one will go here. And the other one that's greater than 45 will go here. Along with those, I still want you to measure the max height of the path and the hang time. So the hard part is measuring something like max height for this. So to measure the max height here, you want to make your tape measure quite small. Alright, so the tape measure, you have to reduce the size of it so that you can actually measure the max height here. And this one's going to be a little bit tougher because it's only a max height of like 2 or 3 meters. So do your best and estimate there. So again, for this problem, you're finding two angles. One is greater than 45 and one is less than 45. Okay, one greater than 45, one less than 45. They're going to go in this box here and this box here. And again, the max heights will be different because one of the trajectories you'll see a big, high, steep parabola. The other one you're going to see a low, low and wide parabola, as well as the hang time will be different. Now, part 2, the only difference is that now you need to have air resistance on. So you'll answer some questions here. And then part 2, you do the exact same thing, but with air resistance. So to do so, take a look at the lab program. See this checkbox here? Click on air resistance. By the way, this is a zoom in, zoom out feature, in case you need to zoom in and zoom out to see. So click on air resistance now, and you'll notice the drag coefficient is automatically defaulted to 0.15. What I like you guys to put it at is 0.5, please. So change that to 0.5. And now what you'll notice is that when you click fire, the object is going to have a red trajectory. Ignore the score here. You don't need to use this target at all. Actually, you can move the target out of the way. You'll see that's a red trajectory, and the red trajectory just indicates that there's air resistance acting on the object. And you'll notice right away that something is different about this when there's air resistance on. So you have to do the same thing. Try and find the max range. See as far as it can go in the x direction. Indicate the angle, indicate the max height, and the hang time. Then do the same other two things, finding the angle that will give you a range of 20 meters with air resistance. Okay? Part 3 is the simplest part. Part 3, what your goal is to change first of all, change your speed to 25 meters per second, assuming that's the speed at which a quarterback can throw a football. So we'll change this to 25 here. Oops, 25. And we want it to get a range of, 30 meters away. So imagine a receiver is 30 meters away from you and you want to throw it. Now you need to do it twice, once with air resistance down here, that's with air resistance, and once without air resistance. And notice that you want it to go a distance of 30 meters, okay, 30 meters. So if you had this at initial speed of 25 and you launch this, it looks like a distance of 23. So you might want to change this angle, make it like 18 degrees, fire again. Well, that one goes a distance of 26.8 meters. Keep going until you get this to be 30 meters. And remember, you can have a low angle or you can have a high angle like this. You can launch it really high up and still get it to go 30 meters. But what you want it to do is you want it to get there as fast as possible. Okay, so you want the quarterback to throw this pass in the minimum amount of time. So think about which angle you're going to use here. And these angles should be different. Besides that, that's all you're going to do tonight. And this is, again, October 15th. That's all you're going to work on tonight. For tomorrow, I have parts 1, 2, and 3 done, and we'll begin part 4, which is the mathematical verification of these values tomorrow in class.